we're going to get on our diploma. Now, probability, you really need to know the last 2 units to do these. And one of the first things that we did in probability was the difference between odds and probability, right? So we do not want to get those mixed up. And yes, they will definitely have 1 or 2 questions. Do you know the difference between the odds and probability? Now, this asked us, after all this is done, they say Bennett, so we're snowboarding here. The odds of falling are 14 to 11 for him. For Carter, 8 to 17. And David, the probability of him falling down is 0.61. So we're kind of comparing apples to oranges right now, right? We need to compare apples to apples, right? It's just kind of like, I don't know if you guys even know why, or even heard of the Iron Man, right? But you you swim, 4K, and then you bike like 160. Yeah, and then you run 26 miles after that. Well, the reason it was created, it was actually in Hawaii. I think Okinawa. There's an army base there, and 3 guys were basically saying, one was a swimmer, one was a biker, and one was a runner, and they're all like saying they're the better athlete than each other. So they made that one event. They put them all on equal ground, right? Everybody was now in a disadvantage of 2 sports, right? So that's how they could tell who was the best athlete, right? Because the cyclists thought, well, come on, I cycle hundreds of miles a month, right? You swim like 20 lengths or whatever. How can you be a better athlete than me, right? And then the runner, of course, well, so that's how they settled it. Well, until you get things on equal ground, you don't know which is which or who's better or whatever. So let's do, because it asks for the lowest to highest probability. Now, we don't know probabilities except for this one. How would we find probability of Bennett? He fell 14 times out of how many times did he go? That's what they would like you to think. Out of, not 22. Out of 25, yes. Yeah, 22. I'm assuming you doubled the second one, which that's not going to serve you very well. Okay? So then you get 0.56. 8 to 17. That means you fell 8 times and 17 times you didn't. But you fell 8 out of 25 times, which gives you 0.68. Now, we're comparing apples to apples. Bennett, he had the lowest probability of falling, 0.56. Then David at 0.61, and Carter at 0.68. He had the highest probability of falling. Oh, did I calculate it wrong? 17 out of 35 is what? Oh, 17, sorry. Oh, yeah. The odds, okay. Yeah, okay. So the odds against falling, see, this is in favor of falling, so we put it there. The odds against, it's funny, I did it right on here, and then I didn't even look at my notes. Okay, so that's how we get 0.68. So this one, extremely tricky, but those are the ones that make you mad when you come out of that diploma and you start talking about it. And someone will go, did you know that Carter, that one said against, not for? Did you catch that? And Eustace, the guy that'll catch that, and he'll be like rubbing it all in your faces hard. I'm calling it right now. You know it, right? Okay. Jamal, Ethan, Alberto are competing with 7 other boys to be on their school's cross-country team. Each boy have an equal chance of winning the trial race. This is a tricky one, but we've done this before. What's the probability that Jamal, Ethan will place first, second, or third in any order? Okay, so first of all, in any order, we have 3 of them, and they will P3, right? Of those 3, how many groups of 3 can we make? And out of the total, which is there's 10 people, how many groups of 3? Okay, so that's 6 over 720, which is 0.008 or 0.8%. Hopefully we're good at moving back and forth the percent. And okay, this making sense? Okay, now this one here, if you can guess, you've got the letter Saskatchewan, you flip all the tiles, okay, and if you can flip them up in the right order, you win a new car. So let's figure out the chances. Now, first of all, how many different ways can you flip up those tiles to spell it right? Larissa, are you with me here? How could you do this? First of all, how many letters? So you have 12 letters, and you have to do repeats. So what are my repeats? 2 S's, 3 A's, any other? Okay, so first of all, let's figure out how many different ways I could flip it up. That's 12 factorial divided by 2 factorial, 3 factorial, which is 399,168,000. 39,916,800. The probability of winning would be 1 out of that number. Yeah, it's not good. You might want to be getting a ride home from that one. Okay, next we talk about mutually exclusive, right? Of course they're going to ask you about this. So, some possible events for rolling a 6-sided die are listed. An even number. Now remember, 2, 4, 6. I would list them all. It just really gets everything so you can see it before you start making any decisions. Number less than 3. You could see how you could get caught up and put 3 accidentally. A number that is greater than 2. Or equal, yeah, greater or equal to 2. So 2, 4, 6. That's weird. Yeah. Okay, and then a number that is a multiple of 3, 3 and 6. Okay, so which two events are mutually exclusive? 2 and 4. That would probably be a numerical response question. Yeah, this one's very common. Particular traffic light in the outskirts of town it's red for 30 seconds, green for 25, and yellow for 5 in every minute. When a vehicle approaches the traffic light, the probability that the light will be red or yellow. So probability of red or yellow equals the probability of red plus the probability of yellow, and you have to subtract the probability of red and yellow if it's not exclusive. Now, can it be red and yellow? No, so you know this is independent. It's mutually exclusive. So what's the probability of being red? 30 out of 60. What's the probability of being yellow? 5 out of 60. And remember, these have a common denominator. So 35 out of 60. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . And remember, I could also have used this. That means or. Hopefully we'll remember that. And that's formulas on your formula sheet. But that's if it's mutually exclusive. Now, Pearl's about to draw a card at random of 52 playing cards. If she draws a face card or a spade, she will win a point. Determine the probability of drawing a face card or a spade. Is this mutually exclusive? Okay, why? Because you can have a face card that is a spade. So it's probability of face or spade equals probability of face plus the probability of spade minus the probability of face and spade. So probability of face card, how many are there? 12. So 12 out of 52. Probability of a spade. $13. Yeah, ace 10, or ace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Minus 3 out of 52. What do we get? It's basically 12 plus 10, right? Yes? 22 out of 52, which could reduce, I guess, to 11 out of 26. Okay. Okay, now this one here, you're definitely going to get one of these, okay? Looks extremely daunting, but if you use your formula, it's actually quite easy. Now the probability, you got to know your wording. The probability of Brenda getting a hit is 0.35. The probability of Brenda or Deborah getting a hit is 0.67. The probability of both Brenda and Deborah getting a hit is 0.224. Now there's a really complicated way to do this, and I've seen it even on websites and stuff, but this is the formula you should be using because these aren't exclusive. So if they're not exclusive, do this. The probability of B or D should equal the probability of B plus the probability of D minus the probability of D and B. Okay, so looks like now I got Bud here. Okay, or and, right? Now, which one of these do we know from the question? Okay, we know Brenda is 0.345. What else do we know? We know the last one is 0.224, right? And that's why if you know your wording, you can go right to the formula. And the first one we know too, because here's my or no, my or, Deborah or Brenda, 0.617. So we don't know this. So you do your math by, you want to subtract 0.345, and right, so 0.617 minus 0.345. We also want to get rid of this, so add 0.224 equals P of D. So they use Venn diagrams to show how to do this one, a couple other ways, and I really like using your formula. Now if you go 0.617, you add, or you subtract 0.345, and you add 0.224. Just verify this for me. Do you get 0.496? Awesome. So you just have to recognize that this is that formula, which some people won't. Okay, next thing, like there's going to be some questions in the diploma, you're going to be like, oh, nice one, I like that. Like this one here. Determine if it's independent or dependent. Okay? Now that's going to be like a 1, 2, 2, 1 like we did with perms or coms on the quiz. But a 4-colored spinner is spun and a die is rolled. Independent. 2 cards are drawn without being replaced for a standard deck of 52 cards. The first card is a king, the second card is an ace. Why though? Without replacement. Hopefully you do not mess that up. Okay. So a child has 8 toy cars, 6 toy trucks. He reaches in and randomly selects 2 toys, one after the other, without replacement. Okay. So what is the probability of getting a car and a car? Right? That's what that's saying. So we're doing probability of car and car. Now since this is dependent, it's probability of getting a car for the first one times probability of getting a car dependent on a car has been drawn. That's how we write it. So what's the probability of getting a car the first time? 8 out of 14. What's the probability? Now you've got it. Look at my car. Put it down. I go in for another car. What's my 7 out of 13. That's huge, okay? I know I'm going to get 7 out of 14s. Don't do it. Okay? Now you could also go 8C2 over 14C2 if you want. This both gives you 4 out of 13. Okay, number 10 I even used for one of your unit exams. Assuming, okay, in a particular class, the probability a student has a video game system is 0.62. In the same class, the probability that a student will have a home video game system and a TV is 0.46. Now it's assuming that the video game system and having a TV are independent. Okay, so they give you that. Now my independent formula is a probability of video and TV is the probability of video game times the probability of a TV. Now which ones do we know? Yes, we know this is 0.62. Yes, we know the and, don't we? Right here is 0.46. So now, how do we solve for this? Divide by 0.62 on both sides. 0.74 is the probability they would have a TV. Okay. Now, number 11 is one of these impossible / easy questions, because if you know the trick, they're pretty easy. If you don't know the trick, they're quite difficult. Now, each day Melissa's math teacher gives a class a warm-up question. If it's true-false question, it's true-false 30% of the time, and it's multiple choice 70% of the time. Melissa gets 60% of the true-false questions correct and 80% of the multiple-choice questions correct. What is the probability that Melissa answers today's question correctly? So this is a very difficult question. Tree diagram, absolutely. So we've got, first of all, let's talk about the test. What's the probability that I would get a true and false? 0.3. That's a probability of true or false. And 0.7, the probability of multiple choice. So if you thought tree diagram on this one, you would have got it right. Except for maybe the last thing. We'll see if that would have caught you. Now, I already gave you that away. So now we got question. Now it's about correct. So what are my chances that I will get, or she'll get that correct? Okay, so correct will be 0.6, and wrong, which is not correct, is 0.4. How about if it is a multiple choice? So 0.80 is correct. And 0.20 if it's wrong. Okay, now what do I do? No one wants to make eye contact with me right now. Is that something I said? So we have a tree diagram. I'm thinking, that's awesome. Everyone's like, hey, that's a nice tree diagram. Now what do I do? Okay, so what is the probability she'll get a question correct today? So we've got to take these and multiply them together, because that's her chances of getting a multiple or a true or false correct today, which is 0.18. Now, what if it's a multiple choice? So that would give me 0.56. Now, question, is it or an and? Can you be writing both those that day? No. So it's either going to be correct on a true-false or a correct on the multiple choice, right? So it should be 0.18 plus 0.56. Now, if you study these notes and you study this question, you put this on your study sheet, you will get this one right where most of the province will not. It's just that simple, 0.74. So you have 74% chance of getting a question right. So we're doing page 26 to 29.